Hello again, this lecture is on projectile motion basics. We're going to be looking at how do we solve problems related to things that aren't just moving up and down but are also moving sideways as well. So like a baseball being thrown or a cannonball or really anything kind of moving through the air but without wings or like a rocket on it or anything like that. As always, you need 3 or more bullet points worth of notes, 1 to 2 sentence summary, and your follow-up questions on Google Forms. But notice that this is a bonus lecture, so it's kind of challenge. I really recommend doing this one if you are considering IB physics or any other upper-level physics class. But honestly, even if you're not, I still recommend it because projectile motion is pretty cool. And it's a lot of kind of the basis for sports, and so it's important to kind of know about this if you want to appreciate sports a little bit more, or many other things in real life. So our ultimate objective is to be able to solve projectile motion problems, but before we get there, this micro-lecture is just going to outline some basic principles that will allow us to do that. So first, let's do a little reminder. If we've got a vector, such as this one representing a velocity, we can break that vector down into its vertical and horizontal components. Meaning, if it's moving, let's say, up and to the right, then that means it has a certain amount of sideways movement, or velocity, and a certain amount of vertical movement, or velocity, and those can be represented by the x and y components of our velocity. So I remind you of this because although it may not seem intuitive, the vertical and horizontal components of velocity actually don't affect each other. So this brings me to the idea of the independence of motion, which is horizontal component of velocity does not affect the vertical component. In other words, sideways movement doesn't affect how long it takes for something to fall, unless it has wings or something like that. So here what we have is a marble being dropped in red and a marble being fired sideways in white, and both of them begin to fall at the same time. And we can see that as they fall, they actually fall the same vertical distance. The only difference with this white one is it's also moving sideways. So the same distance between each second up and down happens for the white and red ones, even though one of them is moving sideways. To see this in action, because I don't pretend you're just going to believe me, we're going to have a little guest lecture from Mr. Paul Hewitt, the kind of writer of one of the textbooks we use. So I'm going to insert his video in here now.
There's a little device here that will shoot a projectile, a little spring here. I'm going to compress the spring. And when I do that, I can put a projectile here, and watch this, gang, a little spring down. And out it goes. No surprise. But I've got another ball that I can put on the end here like this. And when I go like this, it falls essentially straight down. A little bit out, okay? But kind of downish. This one goes outish. Now I'm going to do them both at the same time. And when I do them both at the same time, you guys got to figure out, hey, which one going to hit the ground first? The one that just dropped down, or the one that goes out? A lot of people think, oh, the one that's fired out is going to be in the air for a longer time. You know why? Because gravity is going to start to pull it and say, oh, I didn't know you were moving. Go ahead. And gravity not going to pull so hard. What do you guys think? Let's try it. I tell you what. If you hear this, all A's. All A's. For this course, all A's. Registrar say, Hewitt, my God, Hewitt, you got all A's in your class. I'll say, I had a sharp class, honey. I had a sharp class, all right? All A's. But if you hear this, then you got to do your homework, and okay? Here we go again. Here we go. This next moment may be very important for a lot of you who have your, everything riding in your grade. All right, here we go. Here we go. Listen. What did you hear? How many heard this? Wishful thinking. We'll do it one more time in slow motion. All right? Now you can get a better look this time. Slow motion. Here we go. All right? Same time, gang? Yeah. Gravity doesn't take a holiday on an object just because it's moving.
Alright, so we could see based on that video, you didn't have to trust me, we can actually see it happen in real life, or you could hear it happen in that case. I guess it wasn't real life. But both those marbles hit at the same time, even though one was being fired sideways and one was being dropped. So what this means is when we're solving problems about things that are falling but also moving sideways, so going in kind of a parabolic path, then what that means is we can ignore vertical movement. So kind of like this kid covering his eyes, we can pretend it doesn't exist. So when we're dealing with the sideways motion, we can pretend it's just rolling on a table or something along those lines. We don't really have to deal with the fact that it's moving up and down at all. Similarly, when we're dealing with vertical motion, we actually can just pretend that the sideways movement doesn't exist. In other words, you can ignore it, pretend it doesn't happen. And ultimately what you do is you treat them both separate, and then in the end you add them together, kind of like you would add together two vectors. And that's actually exactly what's going on in that case. So please do 3 or more bullet points worth of notes, 1 to 2 sentence summary, and your follow-up questions on Google Forms.